Hello and welcome to Chemistry Nuggets, where you can polish your knowledge and clear doubts. So friends, today's video is question number 2.6 from NCERT textbook class 11 and the chapter is Structure of Atom. So let's have a look on the question. Find energy of each of photon which, so number 1 is correspond to light of frequency 3 into 10 to the power 15 Hertz, and the second part is have wavelength of 0.50 angstrom. So friends, first of all, we will convert the values. Now here frequency, that is written as mu, it is 3 into 10 to the power 15 Hertz. We can write it in the form of second, 3 into 10 to the power 15 per second. In the same way, we will write the wavelength lambda is 0.50 angstrom. We will write it 0.50 into 10 to the power minus 10 meter, because 1 angstrom is equal to 10 to the power minus 10 meter. Now after doing these conversions, now come up to the first part of the question. So here energy E is equal to h mu, where h is equal to Planck constant and its value is 6.626 into 10 to the power minus 34 joule second. So putting all the values, so Planck's constant 6.626 into 10 to the power minus 34 joule second multiplied by the frequency, that is 3 into 10 to the power 15 per second. Now doing the calculation, first of all this second and per second will be cancelled. Now multiplication, doing the numbers, we will get the answer 19.878 into 10 to the power. Now powers are minus 34 plus 15. So we will get the answer, I think 19, minus 19 and joule. Now writing more appropriate answer, shifting the decimal leftward one step, we will get 1.9878 into 10 to the power. So minus 19 and one step leftward means plus 1. So it will be minus 19 plus 1. So it will become, final answer is E is equal to 1.9878 into 10 to the power minus 18 joule. This is the answer for the first part of the question. Now come up to the second part. For the second part, where we need to find the energy and frequency is given, we will put the formula E is equal to h mu, we knew, and we also know that mu is equal to C by lambda. So we'll put in place of mu C by lambda. So the formula will become h C by lambda. Now putting the values in this, here we can write C is equal to speed of light and its value is 3 into 10 to the power 8 meter per second. Now putting all the values, we can have h is Planck's constant 6.626 into 10 to the power minus 34 joule second into speed of light 3 into 10 to the power 8 meter per second, which in turn divided by the wavelength which we have 0.50 into 10 to the power minus 10 meter. Now this meter and this meter will be cancelled, per second and second will be cancelled. Now come up to number. When we multiply 6.626 with the 3, we will get 19.878 and divided by 0.50 into 10 to the power. Now come to the powers, minus 34 is there, multiply by 10 to the power 8, and the 10 to the power minus 10 from denominator will go up and it will become 10 to the power 10. plus 10. Now adding all the, so minus 34 plus 8 plus 10, we will get, I think we'll get here 16. And it will be minus. So we can write it 19.878 into 10 to the power minus 16, and the unit is joule here, divided by 0.50. So here 0.5 we can write again 10 and we'll remove the decimal. So again the power plus 1 will be added. So minus 16 plus 1, it will be minus 15. Now, and doing the division for 19.878 divided by 5 into 10 to the power minus 15, we got it. So the last and the final answer would be 3.975 into 10 to the power minus 15 joule. And this is the answer for the second part of the question. So friends, remember the formula and just do the calculations. Calculations are very easy, and keep learning, and please like, share and subscribe the channel. Till then, thank you.